Welcome back. I hope you had some fun doing this as well. So let's have a look at what you might have written down on your piece of paper. And just to prefix this, there's no single correct solution here. For pretty much all problems in computer science, there's more than one algorithm of solving it. And actually in parts of computer science, for example in AI, which is my background, we actually leverage that. So we have different approaches for solving the same kind of problem, and in some cases one approach works better, in other cases another approach works better. So we essentially can arbitrate between these different approaches and say that here I want to use this one and here I want to use that one. So what I'm going to talk about and what I will briefly outline now is really just examples of what you might have written down. If you don't have any of these, but if you have other things, that is perfectly fine. If you have only some of these, that is perfectly fine as well. If you have all of these, okay, I guess we are thinking very much alike. That's fantastic as well. But as I said, there is no single solution to this problem here, and many different solutions can be valid. All right, so let's have a look at what you might have come up with. Here's my maze, and I am starting out here. I have reset my progress. I am back to square and level 1. So what am I going to do? Well, I have no information to start with. So to start with, I'm just going to move slightly in every direction just to look around. Okay, so I have done that, and I know that I can move to the left here. I could go up. I'm going to decide to go up because I know that the exit is somewhere around here, and going up seems like a better idea to me. So, okay, I'm going to do that, and then I end up at this L-shaped junction here. Really only have one choice where to go unless I want to go back. So I will just follow this and I will keep doing that. Okay, and then I'm in a dead end. Okay, encountered dead end. Now I want to turn around and go back, but I will only go back until there is another opportunity to go somewhere else. So I'm not going to go back all the way because, well, I've already been there and I know that this is not where I want to be. So instead I will go up here, and this will in fact take me to the exit here. So now level 2. All right, I'm going to apply this part of an algorithm again. Just have a look around here. I want to go up. Oh, that's a dead end. All right, so I will go back, and then I will explore the alternative here. Don't really have a choice where to go, so I will just follow this path here. Here I can go right or I can go left. I know that left is more likely to lead to the exit, and if you look closely, we've actually seen it already there. And then I go to the exit. And again, I have solved this level. So some combination of these conditions and steps, something along the lines of, if there's only one path, I will follow this until I can go no further or I have reached the exit. If I have a choice to make, if I can go in different directions, then I'm going to choose the one that seems to be closer to the exit. So here I've just arbitrarily decided that up is better than left. Of course, you can do this in a different way as well. You can decide that left is actually better than up because the maze is wider than it is high, I think. I'm not entirely sure. I can't see the maze, so I have to kind of guess here and just do a little bit of search. If I get into a dead end, I will turn around and I will go back, but only until I have reached a junction that I haven't explored yet. So I don't want to go all the way back to the beginning and then start again, because that will probably lead me to the same dead end. And something along those lines, coupled with, there might be, well, at this point, I'm just going to stop and I'm going to have a look around. So I'm going to move in all possible directions, because that means that my light will now shine down different directions and enable me to see what the maze looks like. And that will then in turn allow me to make better decisions later for when I have to decide where to go. And if I already know, oh, wait, I've seen this before, I know that this will lead to a dead end, or this actually looked very promising. I could see the exit with my little light there. And that's why I want to go in that direction. So all of these are perfectly valid. As I said, different ways of solving this problem, and different steps, different scenarios. that you can consider here. Of course, what you can do in the classroom is you can have your students do this exercise, and then you can pool the solutions. You can get everybody's rules together and see that, oh, well, okay, this is actually this rule, and oh, you've thought of something that I hadn't thought of, and that's actually really important to consider in practice. And maybe this rule will not work as nicely in all cases, but this is a thing that you can very easily make into a group exercise as well, and have the students talk amongst themselves about how their rules compare and whether you would be able to combine them.